Welcome to the deep dive. Today, we're getting into something pretty invisible, but definitely present in a lot of our lives.
Yeah.
Those wireless signals, specifically the ones coming from, well, right next door.
Yeah, from your neighbors. It's fascinating.
Exactly. We're looking at a really practical story today, an account from Neil over at EMF Safety Zone. He moved into a new apartment and ran smack into this problem.
Ah, the apartment scenario always brings things closer, doesn't it?
It really does. So our mission here is to unpack how he tackled this unwanted RF radiation, that's radio frequency, and the kind of surprising DIY solution he used. We'll look at the problem, his method, and, did it actually work?
And it's a good time to talk about this radio frequency radiation. It's just the energy from our Wi-Fi, our phones, all that wireless tech. It's everywhere.
Right.
But when you're packed together, like in apartments, the concentration, the closeness, it definitely makes people more curious, sometimes concerned. Understanding what's going on is, well, it's becoming more important.
Absolutely. And Neil's story, it's so relatable. You move in, you're setting up, and then boom, you realize your neighbor's Wi-Fi router is like 15, maybe 20 feet away.
Yeah, just through the wall.
Right through his bedroom wall. And then in his office, another neighbor had a cordless phone and wireless internet, just, as he put it, blasting through. He was actually getting headaches from it.
Hmm. And that happens. Headaches are a reported symptom for some people with higher exposure.
So these signals, even though we can't see them, they can be a real issue for some people, especially up close.
Well, yeah. Proximity is key here. Think about it. These devices are designed to send signals out. When the source is just a few feet away, separated only by drywall, the intensity of that electromagnetic field can be quite significant right where you are.
Right.
It's not necessarily harmful in the way we think of, say, X-rays, but for individuals who might be more sensitive or just put that constant close-range exposure.
Yeah, physical symptoms like headaches can occur. It's a real phenomenon for some. Okay, so Neil's got this problem. Headaches, signals blasting through the walls. What did he do? This is where it gets really interesting, right? He didn't call in some high-tech firm.
No, not at all. That's what's so cool about this. He went low-tech, really practical. He headed down to the hardware store.
The hardware store for RF shielding.
Yep. His main material, simple metal aluminum screen, the stuff you use for screen doors or windows. He bought it in these big rolls, like 12 feet long by 4 feet wide.
Wow, okay. Aluminum window screen. So what did he do with it? Just tape it to the walls?
Sort of, but a bit more methodically. He actually tacked it onto the outside of his apartment walls.
Outside. Huh.
Yeah, covering the areas where the signals were coming through most strongly. He even wrapped it around corners, and he put it over the windows, too.
Over the windows? Wouldn't that block the view or the air?
Well, it's screened, so air could still circulate fine. And crucially, this was part of the shielding. And here's a really important detail he mentioned. He made sure that the different sections or layers of screen were touching each other.
Ah, okay. So it had to be continuous. Why is that so important?
That continuity is what makes it work. The idea is to create something like a Faraday cage.
Right, I've heard of those. Like, they block signals.
Exactly. A Faraday cage is basically an enclosure made of conductive material, in this case, the aluminum screen. When it's continuous, it blocks or greatly reduces external electromagnetic fields, like radio waves. The touching sections ensure there aren't really any gaps for the signals to easily penetrate.
So the connected screen acts like a shield, deflecting or absorbing the RF waves.
Precisely. It disrupts the wave's ability to pass through. It's a pretty established scientific principle used in lots of applications.
Okay, so he built this screen shield. Continuous conductive. Was that it, or was there more to it?
There was one more absolutely crucial step. Grounding.
Grounding. Okay, like with electrical circuit.
Exactly like that. He took a piece of copper wire, bolted it firmly to the aluminum screen, then he connected that wire, using a hose clamp, to a copper pipe. And then he just knocked that copper pipe into the ground, into the earth outside his apartment.
Wow. So he physically connected the entire screen setup to the earth. Why is grounding so vital here? Why not just rely on the screen itself?
Well, grounding is what really makes the Faraday cage fully effective, especially for certain types of fields and frequencies. Without a ground, the metal screen can block signals, sure, but it can also potentially accumulate an electric charge from those fields, or even re-radiate some energy. Grounding provides a safe path for any built-up charge or unwanted electrical energy to dissipate directly into the earth. It basically drains it away, ensuring the shield works as effectively as possible to truly block those incoming signals. It completes the circuit, so to speak.
Got it. So screen on the outside, wrapped around, sections touching, and grounded to the earth. That's the setup.
That's the setup. Pretty ingenious using simple materials.
Okay, the moment of truth then. Did this hardware store solution actually make a difference? Did he measure it?
He did measure it. And to understand the results, we need to talk about attenuation.
Attenuation.
That's like...
The reduction in signal strength, right? Exactly. How much weaker the signal gets. Neil used an RF meter, which gives readings in microwatts per square meter. It measures the power density of the RF radiation.
Okay, so what were the readings before and after?
Well, in the bedroom, before he put up the screen, the reading inside was basically just as strong as it was right outside the wall near the neighbor's router.
Wow. So it's coming right through.
Pretty much unimpeded. But after he installed and grounded the screen, Neil reported something like 95, 96, even up to 99% attenuation.
99%. That's huge.
It really is. He said his meter registered basically 0 microwatts per square meter inside peak or average. Just went completely quiet.
That's incredible. And what about the office, where he was getting headaches?
Same story there. The meter went completely quiet after the screen went up. That blasting signal from the other neighbor's cordless phone and internet was effectively blocked. And importantly, he said his headache stopped.
The headaches stopped. That's pretty compelling evidence right there. It really suggests the signals were the likely culprit, and the shield worked.
So, taking this all in, what's the big takeaway here? What does this mean for, anyone listening who might be in a similar boat?
I think the core message really is that you can achieve significant RF shielding using materials that are, frankly, easy to find and not wildly expensive.
Right.
Neil himself pointed out, this was not terribly expensive, definitely cheaper, he said, than buying specialized RF shielding fabrics or curtains, which can cost quite a bit.
That's a really empowering point. It means there are practical steps you can potentially take yourself.
Absolutely.
So for you listening, if you're in an apartment or a house where you suspect signals from close neighbors might be an issue, maybe their Wi-Fi router is right on the other side of your bedroom wall, or you have a powerful cordless phone base nearby, this approach Neil used offers a potential tangible solution, something you could actually try.
It demystifies it a bit, doesn't it? It shows that the basic principles of physics, like the Faraday cage, can be applied pretty simply sometimes.
It really does.
Yeah.
And it makes you think.
Yeah.
Well, it raises this question. If simple aluminum screen and grounding works for an apartment wall, how else could we apply these basic ideas of shielding and grounding? Are there other everyday situations where these invisible signals might be playing a role we don't think about?
That's a great point. I mean, the principles are fundamental. Think about protecting sensitive electronics from interference or ensuring clean signals in, say, a recording studio or even data centers. The physics is the same, just maybe applied differently. Neil's experience kind of opens up that way of thinking.
So this deep dive really highlights how something as common as aluminum screen, if you use it correctly, continuous, grounded, can be a surprisingly powerful tool against these unwanted wireless signals. It's a definite aha moment, I think. It gives you a sense of agency against something that feels so, invisible.
It really does. It shows that simple, accessible materials can sometimes offer very effective solutions, even for modern technological challenges.
A fantastic example of practical problem solving.
And maybe it leaves you with something to ponder, too. Think about all these unseen waves filling our spaces. What other common everyday materials might have surprising properties when it comes to interacting with them? It might just make you look at your own surroundings a little differently.